12. Practice test, page 102. Solve the equation 4 plus root x plus 1 equals x. Graphically and algebraically, express your answer to the nearest tenth. Well, we put the right-hand side of the equation in y1 and the left-hand side, right and left in y1 and y2, and we get the point of intersection to be 6.7912.878. Okay, so we have our solution. Algebraically, what we need to do is to move everything to the root on one side. So we will get root x plus 1 equals x minus 4, x plus 1 squaring both sides. We get x squared minus 8x plus 60. Okay, setting that equal to 0 to solve the quadratic, we get x squared minus 9x plus 15. Now we can't factor this through inspection, so we have to use the quadratic formula. And I'll just put it here. As a reminder, so you know where I'm substituting a, b, and c from our quadratic. So we have x equals negative 9 plus or minus root negative 9 squared minus 4 by 1 by 15 all over 2 by 1. And we end up with x equals 9 plus or minus root 21 over 2. Two possibilities. We have x equal 9 plus root 21 over 2, and x equals 9 minus root 21 over 2. So x is approximately 6.8, or x is approximately 2.2, and 2.2 is an extraneous root. And that would be determined by both the graph and the restriction. I forgot to mention the restriction. So the restrictions on the variable are x has to be greater than or equal to negative 1. Okay, let's take a look at 13. I guess you'd just be able to take a look at the graph to determine that's an extraneous root. The radical function s equals root 255d can be used to estimate speed s in kilometers per hour of a vehicle before it brakes from the length d in meters of the skid mark. The vehicle has all four wheels braking and skids to complete stop on a dry road. Use the language of transformations to describe how to create a graph of this function from a graph of the base square root function. Okay, well, if we take a look for A, we have S equals root 255D. So A equals 1, H equals 0, sorry, B equals 255. I better put that in before I go to H. B equals 255, H equals 0, and K equals 0. So the graph of S equals root D is horizontally stretched by a factor of 1 over 25. Of 1 over 255, I'm sorry, 1 over 255. Sketch the graph of the function and use it to determine the approximate length of the skid mark expected from a vehicle traveling on this road at 100 kilometers per hour. Well, okay, if we take a look in y1, we put the equation. In y2, we put 100 kilometers. And basically for B, the expected skid mark from a vehicle traveling at 100 kilometers per hour is approximately 39-meter skid.